we have n minus 1 choose 2 plus n minus I minus 1. What does that mean? Well, we will then pair up the zeros using n choose 2. But now, since we have now we have only one full square, that one square can be paired with the other zeros above it, only due to the fact that it has a magnitude of 1, and it is greater than the following rows above it, because it is greater only by 1. Therefore, as a result, we have n choose 2 minus I, counting every single value except for I.
And notice that since for area 1, you can go back one.
Sure.
Notice that since this bounce is equal to the div for every single path, we'll say that for this case, for this area, our bijection is the identity. We're not doing anything to the path. Its bounce is equal to div, and that's how we're mapping them.
Okay, now moving on. We have an area of 2. Therefore, we have 2 full squares, and only 2 full squares. Therefore, again, the rest should be 0. Now, we're going to let the location of I, we're going to let I1 be the location of the first square, and I2 be the location of the second. Then we have I sub k, which is the location of the kth square. Noting I sub k is, as previously said before, is the bottom right-hand corner of the square. And that bottom right corner is the y value. Therefore, it is I sub k. Now, we have 2 types of paths, separated and a together path. If we have a separated path, there is no space in between I2 and, there is a space that's in between I2 and I1. Therefore, I2 is greater than I1 plus 1. If we have a together path, then there is not a space in between I2 and I1. Therefore, we could say I2 is equal to I1 plus 1. Now, for example, this is an example of a separated path. Notice the space that's in between I1 and I2. Now, picture for a together path, just literally move I2 to that empty space. That would be a together path. Now, we have to find the bounce and the dim. Starting with the bounce, if we have a together path, if we follow the same order as we did for area 1, we are going to count every single value except for I2. So if we were to go back, if we move this I2 right here, we would count it as normal, and notice that the I2 value is right here. We would then skip over I2, but we would still get I1. Therefore, we would have n choose 2 minus I2, because we skipped over the I2. Now, if our path is separated, instead of skipping over just I2, we will skip over I1 and I2. Therefore, we will count every single value except for I1 and I2. Here's an example, separated path. We're going to go down. We will skip over I2, and we will skip over I1, because we skipped over the points. And now, for all of I1 and I2, for finding the div, we have n minus 2 choose 2 plus n minus I1 minus 1 plus n minus I2 minus 1. And now going back, as before, we have an area of 2. We only have 2 full squares, and the rest being zeros. We can still pair up using the same language. We can then pair up the zeros using n choose 2, and then knowing that we have 2 full squares, the location of I1 can be paired with the zeros above it, and the I2 can also be paired with the zeros above it.
And so now, since we're trying to look at solving this open problem, and trying to for these areas, we kind of need to see what characteristics come about if we set bounce equal to, it's bounce of some path equal to the div of another path. And in this case, what we'll have is 2 different identities, 2 different characteristics of paths, such that we will end up getting bounce of one path equal to the div of the second. And these are the characteristics. Now we can use these to try to find the bijection.